Hello everyone, welcome back to my channel. Going forward, we are going to learn all of the concepts of Java in practical way, then simple theory. So, it is essential to understand the syntax and anatomy of Java program. Let's learn the anatomy of Java in this video. I have already created an empty Java project in STS to start with. If you are not familiar with STS, I suggest you to watch my video on Introduction to IDE for Java Code. Now, I am going to create a class called Anatomy of Java. If you notice, I am creating this class directly under the source root folder. It means this class is going to get created under default package. When we do so, we get a warning message saying the usage of default package is discouraged. For time being, let's ignore this warning. Go ahead and create our class. Syntax to create a class starts with an optional access modifier, and then the keyword class, finally the name of the class, followed by a pair of curly braces defining the body of the class definition. Recommended naming convention for class is to use title case, where each word in the name starts with uppercase. Now we got our class created. We've created this class with public access level. We will discuss on different access levels and access modifiers in a separate video. For time being, just consider one rule, that is, if a class is declared as public, then the Java source file should be named the same as the class name. Though, we can have multiple classes defined in a single Java source file, only one class can be public, and if we have one, then it should be the name of the source file as well. It is not a good practice to define multiple classes in a single source file. Going forward, we are going to stick to that recommendation. The pair of curly braces define the boundaries of the class definition. Every open brace has its equivalent close brace. Currently, our class is just empty, because we haven't defined anything inside the class. Let me try to run this class and see what happens. STS is not even recognizing this as an executable Java program. The reason is, we don't have a main method inside this class. Let me create the main method. The main method is the entry point for the Java program execution. The syntax of the main method is, it has to be static, the name should be main, and a string array as input parameter. Anything inside the parenthesis forms the input parameters. Here, string is the type of the parameter and the pair of square brackets denotes it is an array. An array is a collection of objects. We will soon learn about arrays in a separate video on collections. The curly braces defines the boundaries of the method. Void is a keyword which indicates the method is not going to return any value to the call. Let me try running this application now. Do you notice? After adding the main method, STS has identified this as an executable Java application. Let's run it. The program has completed its execution. Though we have added the main method, the method body is empty. So the JVM has just launched the application. It does nothing and simply terminated as there were no instructions to execute. Let me add some simple instructions to print some messages to the console and rerun the program. Now we see the program has displayed the messages in the console. System.out.println is an instruction to print the argument passed to the system's default output console. Now we may not understand the syntax of this system.out.println, but by the end of this video you should be able to explain them all. Before moving further on the syntax, let's see how to add comments. What are comments and why we need them? We all know that anything written in a program is nothing but the instruction to the computer. What if we need to provide some information on the source code, just to assist the developers reading the code, but not to impact the instructions to the computer? Comments serves this purpose. Comments are information available within the source code to give additional information about the code and to prepare API documentations. They are simply ignored by the compiler and will not affect the program. There are 3 types of comments supported in Java. What I have just generated are called documentation comments. These comments are used for preparing API documentation. The next one is a single-line comment. We can create a single-line comment by starting the line with double forward slashes. And the final one is multi-line comment, which can be created using forward slash followed by a start, an equivalent and star, and a slash. Can you notice the difference in syntax between multi-line comment and documentation comment? Multi-line comment starts with a forward slash followed by a single star, whereas documentation comment starts with a forward slash followed by double stars. We have learned how to create a simple class, how to make it executable by adding main method, and different types of comments and its purposes. Let's move to packages. Now I am going to create a custom package called com.java with uva.package1 and a class inside it. Since the demo class is created inside the package, the very first line in the source should be the package statement. keyword package, followed by the actual package name. It will throw me an error if I remove the package statement. What is a package? In Java, a package is a namespace used to accommodate related resources like classes, interfaces, etc. Java package name has to use all small cases with each level separated by dot. Recommended naming convention is to start with the reverse of your domain name, to have unique package names. Now I have created a package. Java uses folder structure hierarchy to create package structure. You can see the folder structure created for our package under the source root folder. Let's go to our demo class 1 and see how can we added class members. Inside a class, we can have class level members called static members and instance level members called non-static or instance members. Let's start with static members. I have just declared a static variable of type string. The syntax for declaring a variable starts with an access modifier. The static keyword tells it's a class-level variable. The type of the variable, string in this case, and the variable name. Declaration should end with a semicolon. The type of the variable determines what value the variable can store. We can also assign a value to the variable when it is declared, by using equal to symbol, as shown in this example. Let's see how to access this variable. I am going to access it from the Anatomy of Java class. The syntax for accessing a static member is to use the class name, followed by a dot, and the member name. The member could be a variable or a method. Here, I am creating a method local variable called value of a static variable from demo class 1 and assign the value from the static variable of demo class 1. And printing the collected value to the console. I am not sure if you noticed the addition of import statement when I referred the demo class 1. Since these two classes are under different packages, we need to use import statement in Anatomy of Java class to refer the demo class 1. STS has taken care of automatically adding it for us. Now, you may get a question. What about the system class used in system.out.println? We haven't defined the system class in our project, haven't imported that class either. Where did it come from? Why didn't we get a compilation error? The reason is, system class is part of core Java implementation and resides inside java.lang package. Java imports this package to every source file by default, hence, there is no need for explicit import here. Let's run the program and see the result. We can see the value of the static member getting displayed in the console. Let's see how to create a static method and call it. Public, the access modifier. Since we want this method to be a static member, the static keyword has been used. Void, to tell that the method is not going to explicitly return any value to the caller. The name of the method, I am naming this method as a static method followed by a set of parentheses. Every method declaration should have the parentheses following the method name and then curly braces to define the method boundaries. Inside the method body, I am just adding a simple statement to print a message in the console. Now I am going to call this method. The syntax for calling this method is the name of the class, demo class1, dot, the name of the method, static method with parentheses. Let's run the program and see what the output is. We can see the body of the method getting executed on calling the method and printing the statement in the console. So now we have seen how to create static members and call them. Let's move to non-static members, also called as instance level or object level members. Let me create an instance variable and a non-static method. If you notice, the syntax is identical to our static variable and method declarations. The only difference is the keyword static missing for instance members. Let's see how to call this instance members. We just accessed the static members using the class name. Let's try the same here. The class name, dot, but this time, the ID is not showing the instance variable, what we have just added. Let me copy and put the variable directly. When I do so, I am getting compilation error, because, to call an instance variable or an instance method, first we need to create an instance. Let's go and create one. New instance could be created by using the keyword new, and calling the constructor of the class. I have created a new instance and assigned it to a variable called demo class1. Now we can access the instance level variables and methods on the new object we have just created. I'm just following the same pattern of collecting the variable value into a local variable and then printing it in the console. Let's run the program again and see the result. Now we can see the value of the instance variable in the console. Let's go and call the instance level method on the same object and see the output. we can see the instance method getting executed and printing the value in the console. If you notice the name of all the declared variables and the methods, both static and non-static, they all start with a lowercase first letter for the first word and uppercase first letter for all other subsequent words. This pattern is called camel case in Java, and is the recommended naming convention for methods and variables. Let's see some different flavors of methods. I am creating a method with an input parameter. I have named my input parameter as input and it is of type string. Inside this method, I am just going to print the value of the input parameter. I have finished the definition of this method. Let's go and call it. Since this method has an input parameter, the caller should pass an input value. I am just passing a greeting message. Run the program now. I could see the output from the new method in the console. What has happened here is, when calling the method, we are passing a string argument. That gets collected in the local variable input, which is then concatenated with another string literal using plus operator, and passed to the console. Let's call the same method with a different parameter now. We can see the same message with only the difference of the parameters passed. So far, all the methods we have defined just simply returned to the caller once they are done with their task. They didn't return any value to the caller. Now I am going to show you how to define a method which is going to return a value to the caller. What comes before the method name in the definition tells the return type of the method. In the previous examples, it was void, as those methods didn't return any value, whereas this method is going to return a value of type string. If a method is declared to return some value, then it should have an explicit return statement inside it. Here, I am just returning some string literal, say, bingo. Let me call the new method we have just created, and run the program again. I don't see any difference in the output. Where is the bingo? There is no change in the output. Why? Because the caller has just invoked the method, but didn't take care of collecting the value returned. Though the method being invoked returns a value, it is up to the caller whether to use the return value or not. Now I am going to change the implementation to collect the value returned and print it in the console. We can see the bingo displayed in the console. Let's see one more flavor of a method definition. This method is going to have an input parameter of type string, as well as a return value of type string. Let's call this method and see the result. Even though I have used the same type, string, for input parameter and the return type, there is no relationship between them. Basically, methods can have different types for input parameter and return value. In fact, we can also define methods which can have more than one input parameter of different types. These different flavors of methods are applicable for static methods as well. There are some blocks of code within Java class which gets executed automatically during certain events. Let's see them now. I am going to start with static blocks. We just need to use the keyword static and a pair of curly braces to define static block. The static block is simply going to print some message in the console. We cannot explicitly call these blocks. Static block gets invoked automatically when the class gets loaded for the very first time. Let's run the program now and see the results. Let me add one more static block and see what the behavior is. We see the output from both the static blocks. Let's swap the order of the block definition and see the results. When I do so, the output message order also got swapped. This is because, if there are multiple static blocks, they all get executed in the same order as they are defined in that class. Do we have anything equivalent to static blocks for instances? Yes, we have non-static blocks. Similar to static blocks, non-static blocks also gets executed automatically in the same order as their definition, but they are not executed at the time of loading of the class. Instead, they get executed for each object creation of the class. Let me add a non-static block and see their behavior. We can see that the message from the non-static which gets executed during the instance creation of this class. Let me create one more instance of this class and see the results. We can see the non-static block getting executed twice as we're creating two instances. Similar to static blocks, we can also have multiple non-static blocks. Let's add one more block and see the result. If you notice the syntax for creating a new instance, we have used new keyword along with the name of the class followed by parenthesis. This is called the constructor of the class. A constructor of the class is called every time an object is created. Let me create a constructor for our class. The syntax for creating a constructor is to start with an access modifier, and then the name of the class with parenthesis. To enclose parameters if any, followed by curly braces. Now, if I run the program, I can see the message from the constructor getting displayed in the console. Though the constructor definition looks identical to a method definition, there are some significant differences. First, the name of the constructor should be exactly same as the name of the class. Second, the constructed will not return anything, not even void. Okay, we have created the constructor just now, but how were we able to create objects, even before we define one? It was possible, because Java compiler automatically adds a default, no argument constructor to a class, if no constructors have been defined for that class. At the beginning of this video, I mentioned that we should be able to recognize the syntax of system.out.println method by the end of this video. Let's try it now. System starts with uppercase, as per the Java naming convention. Name of Java classes begins with uppercase. So system is a name of a class. We also saw the syntax for accessing a static member is to use the name of the class. Since it is system.out, out should be a static variable of system class. From the syntax of Println, especially because of the parentheses, we can conclude that it is a method. Since it has been called on the instance out, it should be a non-static method of the type out variable belongs to. I am not going to disclose the type. It is the exercise for you guys to find the type of object out. Please share your answer in the comments section. Let's have a quick recap of some of the important points we covered today. We used the keyword class to define a new class. Recommended naming convention for class is to use title case. If a class is declared public, then the source file name should be same as the class name. We can have multiple classes defined in single source file. Source file should have package statement at first when it is created under a custom package. Package statement should be followed by import statements when we access a resource from another package. The main method is the entry point for Java program execution. Comments won't intervene with program execution. The syntax for accessing a static member is to use the class name, followed by a dot, and the member name. To call an instance variable or an instance method, first we need to create an instance. Recommended naming convention for methods and variables is to use camel case. Void is a keyword used to indicate the method is not going to return any value to the caller. When a method is declared to return some value, then an explicit return statement is mandatory. Static block gets invoked automatically when the class gets loaded for the very first time. If there are multiple static blocks, they all get executed in the same order as they are defined in that class. Non-static blocks gets executed along with the constructor for each object creation of a class. Name of the constructor should be exactly same as the name of the class. Constructor will not return anything, not even void. Java compiler automatically adds a default, no argument constructor to a class, if no constructors have been defined for that class. With that, we have come to the end of this session. Hope you guys enjoyed this video. If yes, Please hit like button. Subscribe to this channel to explore more on Java and related technologies. We'll meet you soon with my next video. Till then, bye bye from Yuva.